I, uh, what you have to see is frequently people who have behavioral issues, such as fear, also have issues with maybe weight. And it does make some sense when you see, you know, when we try to show you some of the physiological mechanisms involved with some of these nuclei, you know, it should help tie together some association between different types of behaviors. The arcuate nucleus is monstrously important. There's some dopamine that it produces that's going to go into some reward pathways. Release and inhibitory hormones. These have tremendous effects on the pituitary. We'll talk a little, well, we won't get to neuropeptide Y in general, but we'll talk about POMC in just a little bit. There are all sorts of molecules. This is just kicking out dietary molecules, peptide Y, ghrelin, leptin, insulin, all affect dietary pathways. Some of them increase with food consumption, some of them increase to get you to consume food. So there's a lot happening there. When we get into the posterior group, the posterior nucleus, thermoregulation, the mammillary body, a lot of memory involved with various nuclear areas in there, fibers going to the thalamus, the amygdala, the hippocampus, and then you remember the tuberomammillary nucleus with arousal, sleep, memory, etc. So there's a lot happening. It's a really important set of nuclei. I will put these up right after class. So here, you know, the preoptic group, if you refer to it as the preoptic nucleus, you'll get 100% credit, okay? You don't have to say the medial and the ventral or whatever. And then we have this anterior group, paraventricular, anterior, suprachiasmatic, supraoptic. The middle group with the dorsal medial, the ventromedial, and the arcuate, and the posterior group. So it's pretty straightforward. So let's start looking at what goes on with signals coming from the hypothalamus to the pituitary. I like this figure a lot. This figure really summarizes what goes on with the pituitary. This glob here is glandular. It is only loosely attached to the infundibulum and the posterior pituitary, but it is liberally surrounded and penetrated by a rich vascular supply. The only way you get signaling to the anterior pituitary or the adenohypophysis, those two names, I keep trying to use them together because you'll see one or the other in numerous publications. Same thing here, posterior pituitary neurohypophysis. So the only way you can get signals here is to have signals coming from the arcuate that terminate in the infundibulum. They don't penetrate the anterior pituitary. However, those signals are released into this venous capillary network. This whole capillary network here is a portal system, the hypophyseal portal system. What this allows is release hormones or inhibitory hormones from the arcuate are released in this venous capillary complex. It then washes over the anterior pituitary. At which point, depending on which of the release hormones or inhibitory hormones are released, you will have glandular tissue responding. We're going to look at those in just a minute. Now, when it comes to the posterior pituitary, the chemicals are made in the paraventricular supraoptic nuclei. You'll see these fibers come on down. They release them into this inferior part, or the posterior part of the portal system, where they're released and they circulate. The difference in this case between a hormone and a neurotransmitter is that the hormones are released directly into the blood supply. So we have, in this case, 3 nuclei in the brain, in the hypothalamus, that aren't really just making neurotransmitters, they're making hormones. What's the difference between making a neurotransmitter and a hormone? Nothing. The difference is where they're released. If a molecule is released at a synapse, it's a neurotransmitter. If that molecule is released into the blood, it's a hormone. And that's important to really grab hold of and think about. So, the pituitary releases quite an array of complex molecules. They have been in many respects in charge of your life since around the time of birth till now and into your foreseeable future. Start with what we have going on with the posterior, antidiuretic hormone. Antidiuretic hormone is the hormone that you release in response to water stress. Water stress is always dehydration, okay? So if you become dehydrated, the signals are, collected in the hypothalamus, because if you become dehydrated, your blood becomes hypertonic. That's those signals. Osmolarity changes will be detected in the hypothalamus. Antidiuretic hormone will be released into the hypophyseal portal system, where it then circulates. The target are the collecting ducts of the kidneys. So you remember the nephrons have these collecting ducts. You will now remove water from the filtrate of the kidneys, and you'll produce very, very concentrated urine in small volumes in an attempt to bring that water back into your blood supply to, take care of the hypertonicity, returning it to an isotonicity. Chances are you're not going to do it. You're still going to have to drink something. So, antidiuretic hormone. Oxytocin is, in many respects, one of your wonder drugs. And it's showing you two issues here. There are actually 3 I'd like to talk about. Number 1, contractions leading to the birth process. You have signals coming back from developing fetus back to the hypothalamus, hence then releasing oxytocin. Oxytocin brings those contractions, squeeze, get the kid out. Oxytocin contributes to the letdown of milk. So there are 2 things involved with milk. 1 is the actual production of milk. 2 is the release. Oxytocin has to do with the release. The third component that has received a lot of attention in the last 10 or 12 years is the role of oxytocin as contributing factor to pair bond formation. Oxytocin has been referred to as the, quote, snuggle drug. High levels of oxytocin usually help with pair bonding. As a matter of fact, some people have been trying to show that low levels of oxytocin may actually be involved with the inability to form pair bonds. And there's some good evidence to support that. Not just between mother and child, but between man and woman. In other words, or two partners. I shouldn't say man and woman, partner and partner. Since it could go many different ways. You know, men have oxytocin. And you go, well, why should guys have oxytocin? And the only good explanation is pair bond formation. So, you know, there's always that person who, you know, a long-term relationship is a weekend. And there are other people that get into long-term relationships and they go on for 65 years. So it's kind of interesting. One thing they're looking at are oxytocin levels. All right, so those are the two hormones that are released in the posterior pituitary. Now the anterior pituitary is a bit more complex. We'll go through these. We'll look at a couple of others ultimately, but growth hormone. Growth hormone is an interesting hormone. You release it as a result of, all of these hormones, by the way, are produced and released as a result of signals coming from the arcuate nucleus in the hypothalamus. Growth hormone leads to elongation of the bones, deposition of calcium in the bones, actually a higher metabolic rate, stretching and growing muscles. There's a lot going on. So growth hormone, it's very important. You produce growth hormone from, you know, roughly the time you're born until when? When do you stop producing growth hormone? The end of puberty. When puberty is officially over, when you've quit producing growth hormone. For most people, believe it or not, that can be anywhere from 18 to 25, anywhere in there. And what signals growth hormone to stop producing, well, for you to stop producing growth hormone is production of either testosterone or estrogen. As your gonads reach full maturity and are kicking out plenty of sex steroids, growth hormone production ends. Thyroid stimulating hormone. Growth hormone. Wait a minute, let me go back one more thing. Growth hormone also contributes to your ability to metabolize sugar more efficiently. So it increases your metabolic rate. And as a result, you know, we all know there's that point in time where we just can't eat as many calories as we used to. We have to start giving up some calories. So, thyroid stimulating hormone affects your thyroid. So what it will do is essentially cause your thyroid to produce two other hormones, T3 and T4, triiodoiodine and tetraiodоiodine. Your thyroid is your iodine sink, so to speak. If you take in iodine, it will all be sucked up by your thyroid and it will be used there. If you suck up radioactive iodine like I used to, it will just kill your thyroid. So, yeah. Iodine is critically important for you, by the way. It's one of two molecules that the government regulates. You all get iodine in your diets because of the government. Anything in this country, with the exception of sea salt and kosher salt, that is called salt, must have iodine added to it. And as a result, we've eliminated most thyroid problems by having iodine added to your salt. So it's good for you.